Well, I know I said that the previous video in this series was the final video, but in continuing to play around with the 8-bit breadboard computer here from Ben Eater, I stumbled into a problem that I thought was kind of interesting, with a pretty easy solution once you think about it. But it is a problem that illustrates the sort of difficulties that can arise not from the design of the computer, but from the fact that it's built on a breadboard with lots of wires that can be, when they're pulsing on or off, generating changing magnetic fields that induce currents in other wires. And so here I had a program that I have programmed into this computer that's just supposed to count by 10 up to the place where there's an overflow. When it tries to add 10 to 250, then it's supposed to go back to the start and start all over again. And it does that, but it also has a unfortunate behavior here that prior to starting the count by tens, all of a sudden it displays 170, which I don't want it to do. And so that's of course related to the fact that the command that it's going to execute just before it starts counting by tens has a binary representation of 1010 for the command's name, and then it's supposed to be adding 10, which is 1010. It's an add immediate command that I added to the original commands in this language. And so we'll see it here. First, the command that loads 0 into the display, just in case at the start there's something else there. Then we fetch the command number 1, which is on display here. It's 1010 for add immediate, and then the value it's going to add immediately is 1010 or 10. Okay, and currently there's 0 being displayed on the display there, but another clock cycle putting this into the 10101010 into the instruction register causes it to appear here in the display, which I'm not asking it to do. I don't have the output to the from the bus to the display illuminated here. That's this LED, which though it looks illuminated, it's just because of the brightness of the LED next to it. So I'm not wanting that to happen, and I'm not telling that to happen, but it happens. Somehow, some pulse in all these wires is inducing enough of a current in the wire coming to the OI, the output in bit here, and then on through some yellow wires up to the display to cause it to input what's on the bus, which prior to the clock cycle was 10101010. And so my thought after some reflection is that, this doesn't have anything to do with the logic of the of the computer structure or of my program, but rather with some stray RF in here, and so, or stray electromagnetic energy here. So my idea was to put a bypass capacitor on there. A bypass capacitor is an open circuit as far as 5 volts DC is concerned, which is the signal coming from the EPROMs through the white wire over here to the OI LED, and then on with a yellow wire up to the display. But it's going to be a dead short to ground for a higher frequency pulse, which is no doubt what was causing the problem. So what I'm going to do is very carefully move this wire that's coming to the output in LED, and I'm going to move it up here to where I've already put a bypass capacitor onto the board. And let me just get it set here, and then I'll come back to show it to you. Get the wire into the... Yeah, having trouble getting it into the socket here. But we'll get it. Eventually. There. Finally. There it is. Coming up to this location on the breadboard, right here. And there's a bypass capacitor right there going to an adjacent socket, and then from there to ground. And then I need to reconnect this other side of it to back to the place where it will input a signal here when it's required to get something to display on the output. And so there, what we've done is to move the wire, the white wire coming from the EEPROM over to the output in LED. We move that wire up here where we install the bypass capacitor. Then we need to bring that signal on back down to where it's supposed to go so that we'll be able to get things to display on the output register. So now I'm just going to zero everything. I'm going to press my wonderful button that automatically clears everything. And then we'll start it again. We'll go through it again. This time I'll just let the clock run. Let the clock run here so we can watch, and we will not see a 170 appear there. The first thing that appears is 10, and then it keeps on going from there. So what was required here was a bypass capacitor to keep RF out of the display input pin, and that took care of it. So just a little aside here, kind of lengthy, mainly because I couldn't figure out how to get the, the wire in the socket. Yeah, it's now working fine. It will go on up to there was 170, but it was supposed to show 170 there because we're counting by tens. It will go up to 250, and then there'll be a jump carry. We'll light up this LED up here, and then it'll go back to 0, and there won't be any 170 there either, just 10, 20. Okay, so that's it. Just a video to illustrate some of the weird effects that happen just because we're building on a breadboard.